So good afternoon to everyone. Welcome to the day 2, the session 4 for the FDP on cloud and fog computing platform for IoT application. Today we have Professor Sudip Misra sir from IIT Kharagpur. So before sir will start the presentation, I'll introduce sir to the participant. So Professor Dr. Sudip Misra is a professor in the Department of Computer Science Engineering at Indian Institute of Technology, IIT Kharagpur. Prior to this, he was associated with Cornell University, US, Yale University, US, Northern Network, Canada, Government of Ontario, Canada. He received his PhD degree in computer science from Carleton University in Ottawa, Canada, and master and bachelor degree respectively from the University of New Brunswick, Canada, and Indian Institute of Technology, Kharagpur. So Professor Misra has several years of experience in academic, government, and the private sector in research, teaching, consulting, project management, software design, and product engineering roles. His current research interests include mobile ad hoc sensor network, Internet of Things, computer networks, and learning system, and many more. Dr. Misra is the author of over 300 research papers, out of which 170 of them are in distinguished journals. He has won 10 research paper awards in different international conferences and journals. He also received Faculty Excellence Award at IIT Kharagpur in 2017. He received IEEE ComSec Asia Pacific Outstanding Young Researcher Award at IEEE Globacom 2012. Misra has been serving as the associate editor of the IEEE Transaction on Mobile Computing, IEEE Transaction on Vehicular Technology, IEEE System Journal, International Journal of Communication System by Wiley Publication, IT Communication. Professor Misra has published 10 books in the area of opportunistic networks, wireless ad hoc network, wireless sensor network, wireless mesh network, communication network, distributed system, network reliability, fault tolerance, and information and coding theory, published by various publishers. Sir has also served as program chair in many international conferences, workshops, and chaired sessions, and served as the program committee member. Sir has delivered more than 100 talks in various countries also, like US, Canada, Europe, Asia, and Africa. Sir is having more than 10,000 citations with H index of 51, I-10 index of 214, and Sir has recently listed in top 2% of scientists, and as per the analysis of Guide to Research, he is the best 20 researcher in all over the India. And Sir is also the fellow of National Academy of Science, India, Institute of Engineering and Technology, IIT UK, and Institution of Electronics and Telecommunication Engineering. So with this brief introduction, I request Sudip sir. Sir has some meeting at 4:30. So I request sir to start the session. And I also thank to sir in spite this busy schedule also, sir has accepted our request to give his valuable time to us. Thank you very much, sir. You can start your presentation.
Thank you, sir. Thank you very much, sir, for accepting our invitation, sir.
Thank you. It's always my pleasure. So thank you, Professor Panda and Professor Raut, for inviting me to deliver this talk. I will just take a moment to share the slide.
Yes, sir. Visible, sir. It is visible. Sir.
It is visible.
Yes, sir.
Okay. So once again, thanks to both of you. Thanks to all the participants for taking part in this particular workshop, FDP, as well as taking your time to attend this particular session. So today, I am going to talk about some of the fundamentals of IoT from a different perspective. So I'm going to focus on something called convergence, right? Cross-domain convergence. I'm going to talk about what cross-domain convergence is. So the perspective that I'm going to take is to talk about cross-domain convergence in IoT. And we focus on something called sensor cloud, right? We focus on something called sensor cloud. So what is this sensor cloud? In case you do not already know, we are going to discuss that. And what is this sensor cloud approach to building IoT? So this is what we are going to discuss today. So roughly, I'm going to talk for about an hour or so. And so in between, we are going to visit a couple of basic concepts on IoT. We are going to start with what is the definition of IoT, and then we are going to talk about some of the basic concepts that are involved, how to build simple applications of IoT, student projects kind of thing. And then we are going to talk about some of these cross-domain convergence issues, and then we'll switch our gear to discuss how this IoT building of IoT can be taken up from a sensor cloud perspective, right? So how we can build IoT from by utilizing the technological underpinning of sensor cloud. This is what we are going to talk about now. Okay. And at the end, I am also going to spend a couple of minutes on some of the technologies that we have been building in the Smart Wireless Applications and Networking Lab, the SWAN lab, in the Department of Computer Science and Engineering at IIT Kharagpur. So we are going to talk about a couple of those as well. So let us start with the first things first. So what is this IoT? I mean, so those of you who do not already know what IoT is, so so we do not have a single standard for IoT yet, right? So there are a lot of standardization efforts, but there is a consensus among diverse communities working on IoT that IoT is something which is the interconnectivity of different things, right? So different things means like different physical objects. These physical objects could be anything and everything that we can think of, starting from the toothbrush that we have used in the morning to the rice cooker that we have used for boiling rice during our lunch, or these things could be the air conditioning system or the heating system of the room in which you are sitting at present, or this could be the lighting system that is brightening up the lighting conditions of your room. So these could be anything and everything that you can think of. These different physical objects, these are going to be interconnected in a certain way in order to deliver some valued services. Okay, so let us try to dissect this term IoT, Internet of Things. So in the same way as we have the present day internet, which is basically the internet of computers or computing devices, Internet of Things, on the contrary, talks about how you can internetwork different things, and these things are the ones that I just mentioned. Said this, it is not that when we talk about IoT, we are getting rid of the existing interconnectivity of different computers or computing devices as in the internet. We are not getting rid of those, but we are expanding our horizon in order to include these different physical objects. Okay, so how can we build these things, right? So first of all, first we need to understand so how what will be this so why we at all need this kind of thing, right? So why we need Internet of Things. So for this, we need to understand that there are a lot of different services, right? Offered by the government, offered by the society, offered for personal welfare or for different reasons. There are so many different types of services we can think of, which can be made better, can be made efficient through the integration of these different physical objects around us in order to make the quality of life better for all of us. Okay, so we need to take help of something called the embedded systems or embedded objects, right? Embedded devices, and I think all of us, we have heard of the term embedded systems. And so these different objects, these physical objects, basically these are powered by these embedded systems technologies. So these can be safely called as the embedded devices. So these embedded devices are going to act as different identifiers. Are going to have different identifiers which are going to help them to be identified uniquely in the network. And basically the whole idea is that the moment you have a network, you need some kind of an unique identifier in order to be able to identify which device is what. So you need some kind of a uniqueness over there, in the same way as we have, let us say, the IP address to a unique identifier for identifying different devices connected in the internet. So similar kind of identifier we need. And it should be possible to have some kind of communication taking place between these different physical objects without much of human intervention. Ideally, there should not be any human intervention at all, because what is expected is to have a completely autonomous system, but that is more like so the something that is a far or distant vision. But in typical cases, what is expected is that with minimal human intervention, the system and the communication between these different devices, these should be able to be there. Now, so for this, you need some standard protocols. You need some different types of communication protocols. These protocols, again, they should be interoperable between them, because if we are talking about diverse types of systems, and these systems run by different protocols, as such, it might so happen these different protocols, because of lack of unique standard, etc. So these protocols, they have to talk to each other. They are powered by their individual standards, but these standards may not be talking to each other. So how you can make these standards interoperate? So you need some kind of an interoperable communication protocol. Okay, so I hope that I could give you a little bit of idea about the whole premise of what IoT is and how you can build IoT based systems and what constitutes an IoT system, right? So as I was telling you, that there is no single consensus on what IoT is, but there is something like the common belief about what IoT constitutes, and this is what people try to visualize IoT to be. So there are so many different definitions of IoT, and the one that I talked about so far, this basically was part of our Government of India draft on IoT, taken from the Ministry of Electronics and Information Technology. And so like this, so there is a lot of overlap, but there, like this, actually there are so many different other definitions that are out there. One of the things that I would like to point out at this point is that, so what is going to happen is that when you have this kind of a system, and so there are so many different objects around us, there are two things that are going to happen. Number one is that you need some kind of a unique identifier, right, in order to be able to establish some kind of a communication mechanism similar to the internet. So you need some kind of a unique identifier, but the main problem with the unique identifier is that the existing IP based identification, right? So this is not going to be useful, right? Because IP v4 is typically the most commonly used one, even though IPv6 is there. So IPv4 or even IPv6, these are not sufficient due to the limited address space that they have. So you need some different type of addressing mechanism. So because even if you think about a smart home kind of application, right? So typically in a full-fledged smart home application, you just one home, you are talking about interconnectivity of a couple of hundred devices, right? Typically, if you want to have full-fledged interconnectivity in a full smart home application. So this is there, and on top of this, if you want to interconnect different homes in a city, right? So there could be lakhs and lakhs of homes in a particular city, and so you want to interconnect all of them, etc. It's going to be a single network. So how you are going to? So scalability will be a huge issue, as we can understand, because of the lack of unique identifiers and adequate number of identifiers to be made available. So this becomes a huge problem. So how do you deal with it? So this is one. The second thing is that so we are talking about what we have to have fully autonomous systems. So you need to have appropriate sensing technologies in place, and these sensors so these sensors, they are continuously, they are going to sense, and they will continuously, they will sense, and they will throw the data out from the sensed device. And finally what is going to happen is that the device, I mean, the data will have to be made sense out of, right? So you have to make sense out of the data. So the data will have to be processed. Okay, so the data will have to be processed in order to make sense out of what is going on around the sensors which are deployed in these different physical objects. So the humans may so basically the humans in this kind of system, they become minority of in terms of the generators and receivers of traffic, and basically because of the large number of devices that are connected. So how do you deal with such huge volumes of data that are coming in through a single pipeline? So how do you deal with it? How do you store? How do you process? How do you analyze? So these are the things that will also have to be looked into thoroughly. So like this, there are so many different considerations that have to be taken into account. Those of you who would like to learn more about IoT and do not already have sufficient background, so I would encourage you to have a look through my NPTEL lectures. So NPTEL SWAYAM, they also have certification, possibilities of certification, those of you who want to do it. And these are video recorded lectures which are available online. And somehow I have two relevant courses. One is Introduction to Internet of Things, the other one is Introduction to Industrial Internet of Things and Industry 4.0. Both of these are parallelly run every semester, and these are so huge, highly popular courses that every time together we get more than like 40-50,000 registrations. Okay, and so this is something that I would like to give you a pointer. Another thing that I would like to also mention is that there are no suitable textbooks that are available in the market, Indian markets particularly, which can be used for academic purposes in universities, right? So there are some IoT books that are available for maybe professional use, but in the industries or industry professionals may be able to use them, but nothing of the sort for almost nothing of the sort for use in the academia, right? So keeping that in mind, I and two of my co-authors, we have authored two books, one on Introduction to Internet of Things. The other one is the Introduction to Industrial Internet of Things and Industry 4.0, keeping in mind the academic relevance of these two topics, right? And these have been written in a very textbook like fashion. And the first book, Introduction to Internet of Things, it is being published by Cambridge University Press, UK. I mean, actually, it was supposed to be released in the Indian market on the 15th of this month. That means 2 days over. So I'm not sure. I did not get any update. But even if it has not been released so far, within the next, by the end of this year, definitely it will be there in the Indian markets. Or you can order online as well. So book, I believe that the book is not going to be too pricey. Because this is something that I insisted the publishers to do, but I'm not sure within my control. So this is one. The other book on industrial IoT, it is being published by CRC Press US, and that is also a textbook type of treatment that has been given to that particular book. So both of these books would be good additions in case you want to pursue a career on IoT, or you want to learn further, or you want to adopt as a teacher, you want to teach the course on IoT, introduce the course on IoT in your colleges, and you want to adopt a textbook. So you can definitely, I would urge you to consider these two textbooks that will be soon available by the end of this month for sure. Okay, so you don't have to contact me, but these are all going to be there. If you contact the publisher at most, I think you should be able to get copies of these books. So having said this, let us again go back and talk about what we were discussing about IoT. So I have given you a brief idea about what constitutes IoT, how you can build IoT, what is the necessity of IoT. But let us now talk about a little bit more on the complexity that is involved in building IoT. when you are talking about some kind of IoT implementation, one of the things that comes to everybody's mind is the smart city. So in a smart city application, IoT is an integral technology that is often considered, right? So in fact, the other day, 2 days back, I was a panel speaker in the panel discussion on ICT for smart cities in IEEE ANTS conference, IEEE ANTS conference, which is a core conference supported by the IEEE Communication Society. So I was speaking a lot on the on the issue of use of IoT technology for building smart cities. And so let us say that we want to, I mean, just as an example, we want to build a smart city like the one that you see in the bottom right hand side figure in front of you. So as you can understand that in a city, you have what? You have, let us say, traffic system, you have traffic system, you have schools, you have hospitals, you have, public malls, shopping malls, you have judiciary, you have what you have many things, right? So you have so many different things, right? So places to park, parking spots, etc. So many different things are there in a typical city. So when you are talking about a smart city, basically, all of these things that are there in a typical city, they all remain, but you try to increase the efficiency of the operational efficiency of the different segments in a city, right? So how do you improve the efficiency? By one of the ways, one of the popular adoptions of technology is basically the use of IoT networks. So basically you have sensors, sensors which can talk to one another, sensors which can send data through a multi-hop. This data, they reach the intended destination node, etc., like that. So you basically, you try to, one of the popular ways is to basically integrate IoT technology into these cities, right? Plus, IoT alone cannot make you build smart cities. There are so many different other technological as well as process considerations that will have to be made while building smart city. But this is something that is of interest to us for people who have been working on IoT. Are convergence, cross-domain convergence. I promised to talk about cross-domain convergence. What is this cross-domain convergence that we are talking about? So, in a typical city, as I was telling you, there are so many different application domains. These application domains, they have to talk to each other. In a typical use case, right? For example, a child in the school falling down, hurting himself or herself, going to the hospital and encountering a congested road in between, taken in an ambulance, put to the nearest good hospital with good facilities, being treated, etc. So this kind of use case, if you think about, so many domains are involved. There is some kind of cross-domain convergence that is required among different domains, such as education, right? Domain of education, application domain of education, transportation, road transportation, then the medical domain, that means healthcare, then like that, governance, right? E-governance, smart governance, etc. So these, so like that, actually, there are so many different domains that are involved when we are talking about this kind of realistic applications to be built. So these different domains, they are not going to talk to, they are not going to talk or they are not going to execute in isolation, right? So they have to talk to one another. So you need different types of different types of technologies which can mitigate the interoperability issues that come into picture as a result of this. So typically in an IoT, any kind of IoT application, when you are building, you are talking about different work areas such as smart governance, smart agriculture, smart living, smart people, smart economy, smart mobility, smart environment. And like this, these are only a few that I have mentioned. Like this, there could be different other smart X, Y, and Z, right? So these different smart X, Y, and Z, they do not work in isolation in typical for the fulfillment of typical use case scenarios, right? So they have to be integrated. So for this, you need this cross-domain kind of convergence concepts that will have to be built into these systems when they are used for developing realistic applications. So this is the cross-domain convergence, and so we need typical, typical applications. They would need the realization of cross-domain convergence issues of technology. Going back a little bit, at the outset, I talked about one of the issues with the addressing, right? So I told that some kind of a unique identification mechanism will be required, and typically we know that with the IP address we have already run out of the address space, right? IPv4, then IPv6 came into being, and so on. So, but it has been observed that whether it is IPv4 or even like IPv6, etc., so for IoT. Given the nature of scalability that is required, given the nature of complexity that is involved in IoT, typically you do not really have the so you do not really have the luxury of falling back on IP based addressing mechanisms, right? You need to come up with something new. So towards that particular objective, there are so many different initiatives that have been started globally. And these initiatives, they talk about how to uniquely identify different devices. So there are so many different concepts that have been proposed in the meanwhile, and many things are in the works right now. So there is no single IoT, addressing mechanism that is available yet for unanimous use. So on top of that, you need integration of different technologies, communication technologies, for instance. So such as cellular talking to Wi-Fi, Wi-Fi with Ethernet, Ethernet with BLE, BLE with -7, -7 with 802.15.4, like that. So this you need this kind of cross-domain interconnectivity, cross convergence. You need convergence of different heterogeneous devices, heterogeneous protocols, heterogeneous systems you need in order to make them function in a seamlessly integrated manner. So this is basically the complexity that is involved, right? So in a typical IoT scenario, you are talking about typically 4 layers of implementation. At the very bottom we have the sensing layer, then we have the network layer, the service layer, and the interface layer. So sensing layer typically talks about different types of sensors, physical sensor devices such as RFIDs, BLE devices, then different intelligent sensors, etc. So these sensors, they continuously sense what is going on around them, and they send the sensed information through a data sensing and acquisition protocols bus to the network layer. And this network layer, basically what it does is that it constitutes different types of networks, such as the internet, mobile network, wireless local area network, sensor network, social network, and so on. So these different networks, which are the constituents of this network layer, they are going to be useful for sending this sensed data from the sensing layer, and the sensed data is going to be finally sent to the service layer for further processing. Now you see that the sensing layer, network layer, interface layer, these are the terms that you have heard typically even for the internet, right? So no, not the sensing layer, but the network layer, interface layer. So you have encountered, even though they do not really map exactly the way these terminologies occur in OSI or TCP/IP, but we have all heard about these things typically. So we have the sensing layer, then we have the network layer, the service layer, and the interface layer. What the service layer does is that it gives a focus on the IoT applications on the services, right? So services. So these services could be like service division, service integration, creating service repository, maintaining the services, executing different business logic, and so on. So this service centricity is something that is typical of IoT networks, right? So we'll come back again on this services issue again in a short while when we talk about sensor cloud. But let us just complete this thing. The last layer on the top is the interface layer. It is very similar to the applications layer for OSI or TCP/IP. So it is very similar to that. So this interface layer, basically, it runs different contracts. It serves different interfaces, application APIs, front ends, etc. So these are all served as part of the interface layer. Now, so we have when IoT was becoming popular, cloud computing technology was also becoming popular, right? So then people talked about how we can integrate these two powerful technologies, IoT and cloud computing. While IoT is very good in terms of information acquisition, information dispersal, but IoT is not very good on its own on storing the data, on processing the data, and so on, right? So IoT is good for sensing and communicating. So leveraging on the advantages of cloud computing, one can think about an IoT cloud computing framework of the sort that is shown in the figure in front of you. At the very bottom, we are talking about sensors, physical devices, and the network of sensors, connected sensors at the very bottom. Then you have in between the cloud computing layer. Here, actually, we are talking about different service models of our cloud, such as software as a service, platform as a service, infrastructure as a service, and so on. So here you are talking about technical issues of visualization, computation, analytics, storage, all of which need to be considered. And then on top, you have the applications layer. Here, actually, you have different applications such as surveillance, critical infrastructure monitoring, environment monitoring, health monitoring, smart transportation, and so on, which could be used in order to, which could be executed in order to serve the stakeholders, such as the citizens of a smart city. So we'll talk a lot on this services issue. We'll talk a lot on the cloud computing aspect in a short little while. But before this, let us complete our understanding of what are the different features of autonomy in IoT. So as I told you when I was discussing about this definition of IoT, I told you that what is desired is to have full autonomy, right? So fully autonomous system where there is minimal or no human intervention of any kind, right? So for realizing this kind of a dream, you need this, you need a set of features of autonomic computing to be adopted in IoT. Some of these features include self-adaptation, self-organization, self-configuration, self-healing, self-description, optimization, protection, discovery, matchmaking, and energy supply. So these are some of these different features of autonomic computing which have been borrowed from there, and these have been made available for use in IoT. These are not everything to be implemented, but these are some of the ones which could be implemented for improved performance of different systems, and to be able to ensure that the requirements of the communities are catered to properly. When we talk about internet, so we know that we talk about any node, the device, the computer. We talk about two different devices to be connected with each other, or even it can be even more, where more than two devices may be connected to one another. So gradually, from the node level, we are talking about use of gateways, proxies, etc., and building networks such as local area networks, wide area networks, and so on, right? So basically, so you try to build upwards, right? So with the help of these different building blocks. Let's talk about So having understood all of these different types of different types of concepts that are involved in building IoT, let us talk about how to build IoT, and particularly if there are some students or even the teachers coming from different colleges, right? So if you are the one who wants to build the first simple application of IoT, implementation of IoT, so you can do that with the help of your smartphones itself, right? So you can turn on the different sensors that are there on your smartphone, right? So there are so many different sensors, 3 sensors to 7 sensors are typical in most of the smartphones nowadays. So typically, if everybody they turn on their smartphone sensors, these smartphone sensors, they are going to continuously sense and send the data that they are supposed to send, they are supposed to sense, and that data through the wireless network, router, the network, internet, through WebSocket, etc. These are going to interface with the cloud server. This cloud server is going to do any kind of processing that may be involved, and that processed information is going to be sent back to the original source, that means the smartphone, in order to make sense out of what is going on around. So this is another simple IoT app implementation, a student kind of project that anybody can do. So here actually you are replacing the smartphone and the smartphone sensor with a real sensor node. A real sensor node, any sensor node typically has the features of sensing, then communication and processing. So you have any sensor node in IoT has typically the components sensor, then the radio and the processor, in the same way as we have seen in the case of this particular figure. So this every device sends the data via the gateway, the proxy server, through the internet to the cloud server for further processing. Okay. So at the cloud server, there are 2 things that will have to be done. One is to store the data appropriately, and the other is to make it available in the form of processed data, processed information. So analytics, basically analytics is the one. And based on the analytics, basically the actuation in the network is going to be performed, right? So there are so many different enabling technologies for IoT, and I'm going to speak very fast, very quickly on some of these different technologies. So I'm going to keep myself at the higher level, but if you are interested, you can dig deep down into some of these concepts that are involved. So I'm going to keep it simple, because probably we have a heterogeneous cloud and with a crowd over here, and we do not really know who comes from what background, right? So when we are talking about the wireless networks, typically, as most of us know, that any wireless network is comprised of 2 types. One is the infrastructure-based networks, and the other one is the infrastructure-less networks. So infrastructure-based basically relies on fixed infrastructure, and the base stations or access points are fixed and centralized. For example, wireless local area networks, cellular networks, and so on. And the infrastructure-less, basically, there is no fixed infrastructure like base point, etc., to be tied tied to, and there is no centralized access point, and so together, it forms an ad hoc network. So what is this ad hoc network then? So basically, ad hoc networks are multi-hop networks. They do not require any infrastructure. And the beauty of these is that you do not have any access point, you do not have any base station, but still the communication can take place. How? Because over here in these ad hoc networks, and sensor networks or IoT networks may also be construed to have some of these properties of these ad hoc networks. So the PN nodes over here, they take part in relaying the information, right? So the PN nodes take part in relaying the information, and these could be self-organizing or self-configuring in nature. And the situations in which they are useful is to take care of situations such as to need to set up a network fast, for example, at the times of emergencies like 9/11, etc., and relief operations, 9/11, 6/11 relief operations, right? So for these you need to take help of these ad hoc networks. Because the existing, you might ask that why because the existing communication infrastructure basically has collapsed, right? So if the existing infrastructure has collapsed, so basically, you need to have some kind of a makeshift, very quick kind of implementation, which can help the systems to perform, right? So now See these wireless sensor networks. So let us now talk about. So having understood what is an ad hoc network, wireless ad hoc network, let us now try to understand that what is the sensor network. So typically, why we need to understand what is a sensor network is because typical IoT networks constitutes different sensors, connected sensors. So typically, what happens is you have a network of different sensor devices, right? So typically, this becomes a sensor network implementation or deployment. So these wireless sensor networks, they consist of a large number of sensor nodes that are densely deployed in an area, in a terrain. And the sensor nodes, these are capable of collaborating with one another and measuring the condition of their surrounding environments with respect to measuring physical phenomena, physical stuff like lighting condition, temperatures, sound, vibration, etc. And then the beauty is that the sensed measurements are then transformed into digital signals and are processed to reveal some of the properties of the phenomena that are occurring around them. Due to the fact that the sensor nodes in WSN have short radio transmission range, intermediate nodes act as relay nodes to transmit the information to the sink using the data multi-hop path. There are two types of wireless sensor networks. One is the stationary sensor network. The other one is the mobile sensor network. And typically, every sensor node, it has different units for sensing, processing, transceiving, that means communicating, and there are other units like a battery unit for powering up the node, and any other application dependent units which may be optional like the location finder system or mobilizer unit and so on. These are some of these shapes and sizes of some of these small sized MEMS based sensors. As you can see, that these are comparable to the finger size of the fingertip or very similar. So these sensor nodes, they are multifunctional. That number of sensor nodes used depends on the application type. Same, so multiple for the same application, you might involve, various types of different types of sensor nodes. So these sensor nodes, they have short radio transmission range. They have an operating system, for example, TinyOS, and they are battery powered, having limited lifetime. So some of these different applications of these sensor networks or even IoT networks is temperature management, temperature measurement, humidity level measurement, lighting condition, air pressure, soil makeup, noise level, vibration, and so on. These are some of these different types of sensors that you can see in front of you, which are deployed. Even like the second picture that you see is for a sensor for cardiac monitoring, right? So for these are sensors inside the human body, and cardiac monitoring would be done from outside the body, right? So this is the beauty of these kind of sensors. So this is one like this. Actually, there are so many different types of sensors that are available. These applications of sensor networks or IoT networks also include post-disaster relief, post-disaster healthcare, and so on. So this is a typical picture, as you can see, that is constituted when you are build different types of healthcare applications of the sort that is given in the figure in front of you. Different challenges of these sensor networks. And when I say sensor network, we are talking about IoT networks as well, right? So there are different issues such as scalability issue. That means providing acceptable levels of service in the presence of large number of nodes. Typically, the throughput decreases at the rate of 1 over square root of n, where n is the number of nodes in the network. Then you have issues of quality of service, for example, offering guarantees in terms of bandwidth, delay, jitter, packet loss probability, and so on. So why there is a problem? Because we are talking about in typical IoT implementations, we are talking about an environment with very limited bandwidth, unpredictable changes in RF channel characteristics, and many other different types of constraints. So energy efficiency is very important, because in the moment one node is down due to not having sufficient power, then the other nodes they are not going to cooperate with one another, because cooperation means like you will be expending additional amounts of energy. So how you can deal with this kind of energy issues is also something to be witnessed. And then security is very obvious, because you are talking about open medium, wireless medium, and wireless mediums are very much prone to different types of malicious attacks, infiltration, eavesdropping, etc. So now, so we are going to talk about the sensor cloud. I told you that we take in the lab, in this last couple of years, we take a sensor cloud approach to building IoT systems. So what is the sensor cloud approach that we are going to see in a short while? So just I will what I will do is just take a 2-minute break, and then I'm going to come back and continue. Okay. Okay, so let us now continue. So so far what we have talked about is typical implementations of sensor networks, typical implementation of IoT networks using single application based scenarios. But in typical day-to-day life, we encounter scenarios where these are not single application centric, right? So you need some kind of an application convergence, you need cross domain convergence, right? So some of these applications I told you already. So for that, actually one of the ways to handle this kind of thing is to for every application domain you need to you need to deploy different types of sensor based services, and the moment these application services are not going to be there, you remove the installations and redeploy the infrastructure elsewhere, right? So typically one is going to do that, but can there be a better way, right? So there can we utilize some advanced technologies in order to address this issue of cross domain convergence and offering advanced levels of sensing services to multiple end users at the same time, right? So for this the concept of sensor cloud very popular. I hope that all of you are able to see my slide. I'm just making this assumption. So in case it is not, just let me know. Okay, so for this actually, this sensor cloud became very popular, and more than a decade back, actually, we started working on the concept of sensor cloud, and at that time, sensor cloud was not very popular, and so there was some 1 or 2 white papers here and there with not much of analysis. It was more of a concept, but these concepts also were little primitive in that sense, and so we started we in the Swan lab we started working on something called sensor cloud. So this sensor cloud, basically, as this name suggests, it's it's kind of an integration of two technologies. One is the sensor technology, the other one is the cloud technology. So sensor technologies are good for sensing and acquisition of data, whereas the cloud technologies are good for storage, archival, analysis, processing, fast processing, and so on, right? So these are the advantages of cloud computing. So we wanted to so when we talk about sensor cloud, we want to put both of these two different worlds together in order to have a very powerful kind of a system, right? So so we explored how how cloud-based sensor cloud-based platforms can be built. So before I talk about more about this sensor cloud, let me just give you a little bit of formal definition of what sensor cloud is. So sensor cloud is an infrastructure that allows truly pervasive computation using sensors and interface between the physical and the cyber worlds, the data compute clusters as the cyber backbone, and the internet as the communication medium. So this was a definition that was given by MicroStrains. This is the company which this and another company, IBM, basically these were the ones to come up first with the concept of in some of their white papers. But so these concepts basically remained the way these were proposed, but not much was done. So all people were doing is to to integrate these sensor network technologies to the cloud computing backbone, right? So this was what was done. But we took it up, and in our paper that is given at the very bottom right corner, as you can see, a theoretical modeling of sensor cloud, a paradigm shift from wireless sensor networks, which was published in 2014 in the IEEE Systems Journal. In this particular paper, we analyzed sensor cloud. We gave an architectural platform uniqueness of sensor cloud, and we then put a theoretical model that could be used, because theoretical models are very important, right? So because for researchers you need to have some kind of a theoretical underpinning. So we proposed a theoretical model of sensor cloud that could be used for that could be used further for building this kind of a IoT network IoT kind of system, right? So am I audible? Can somebody confirm?
Yes, sir.
Yes, sir.
Okay.
Audible, sir.
Okay. Yeah. Okay. Okay. Good. Yeah. So we we built upon this concept, and then we proposed some of these concepts of theoretical model, etc., in this particular paper. So I urge you to go through this particular paper, and you should be able to get a fair understanding of what constitutes sensor cloud, what are the different constraints of sensor cloud, and so on. So let me go back once again. So there are two possibilities, right? One possibility is that you purely integrate sensor networks, get the data, and instead of storing it in a server, you store it in the cloud, right? So this is what many people visualize sensor cloud to be, right? But we went a step ahead and we conceptualized sensor cloud to be something even more. We talked about offering sensing services, right? So in the same way as cloud computing talks about computing services being offered to individuals on a subscription basis without them having to basically procure the necessary computing infrastructure. Here also very similar kind of parallel was drawn. We thought about how we can have a very similar utility based model similar to the cloud computing model to offer sensing as a service, right? Sensing as a service or sensors as a service, both are very similar, although there is some fine line of difference between these two. So we talked about this, and so the whole idea was that if really I need some kind of a sensing service, we have to go to the market, procure the necessary IoT devices, deploy at the designated place, and start getting the sensing services. I do not really need to do that. Rather, I can use the existing sensing services that are provided by the appropriate service providers. We can use those services on a subscription basis, pay-per-use basis. So whatever of sensing services I need, I should be able to use them by subscribing to those many units and pay for only those many units. So this becomes a more scalable model, particularly for enterprise-based scale. So enterprise level scale. So these become more attractive. So even though it is very attractive and it is very similar conceptually to the cloud computing model, because in cloud computing you have computing as a utility, computing as a service, And over here, we are talking about sensing as a service or sensing as utility. So very similar, parallels drawn. But even though there is a lot of similarity between these conceptual similarity between these two, but there is a huge problem when you try to build sensor cloud. So technologically building technologically building sensor cloud or offering sensing services to individuals, technologically it is very challenging. There are so many issues that will have to be worked upon, and these are the problems for which solutions from cloud computing cannot be adopted as such, right? So how do you so even though conceptual similarity is there, but how do you build this kind of model is something that has to be understood. So this is one. The other challenge is that this kind of model is applicable only for a couple of use case scenarios. But this is, so far, this cannot be diversified to a large extent, right? Only for few application domains, few application scenarios, this is good enough. But for certain application scenarios, this is not going to work, right? Or at least the state of the art is such that it is not going to work. So maybe, in future people are, so there is so much of research since we started basically working on sensor cloud. Since then, a lot of work has been started in India, in China, in US, in Europe. A lot of work is going on sensor cloud, right? So let us now try to understand, keeping these two limitations in mind, let us now try to understand further what is this sensor cloud. So in sensor cloud, it is the acquisition of data feeds from numerous sensor networks in real time. So you have different regions where different large scale sensor networks are deployed, and you get the data feeds from these numerous regions deployed sensor networks. In real time, you are going to get the data. So it is that you need some appropriate mechanism for real time processing of this heterogeneous data, and we have to keep in mind that the data is heterogeneous because the sources themselves are heterogeneous. If the sources are heterogeneous, the data becomes heterogeneous, and in order to take timely critical decisions, you need to have real-time processing in place. So for this, basically, if you integrate with the cloud computing technologies, this basically will be able to take care of the processing to an extent. But on one hand, you need highly swift data processing using immense processing power of the cloud to provide quick response to the user. And on the other, you also need to have analysis of flow of revenue for each of the actors that are associated with the sensor cloud architecture. Because everybody has to be paid. Whoever is involved, the owners of the sensors, the providers, sensor cloud service provider, they all have to be paid, right? To have the flow of revenue to the appropriate stakeholders. So what will be the pricing model that will be there, which will be implemented in order to make this kind of model sustainable? So the whole idea is to virtualize the physical sensor nodes, and then you think about catering to the individual requirements to serve multiple applications at the same time to the different individuals, different users. So the theoretical modeling of sensor cloud, which I talked about, so this basically, in this paper, we talk about how you can take care of these issues. So, so added to all of these, there are different other performance issues. For example, if there is a fault, a node goes down, a link goes down, or anything else, any other component goes down. So how do you deal with faults? What are the fault tolerance issues, etc.? Taking care of the lifetime of the sensor node, energy consumption, etc. So these are some of these issues that will have to be taken into account. Now, in this particular paper, in the IEEE Systems Journal, we also talk about drawing a parallel with wireless sensor networks. So we have made a comparison between wireless sensor networks and sensor cloud. So we show how this concept of sensor cloud is a paradigm shift from the traditional sensor networks. It's a paradigm shift, right? From wireless sensor networks. So in wireless sensor networks, typically, it is single user centric. at most one application can be served at the same time. On the other hand, in sensor cloud, because of the nature in which these are, the sensor devices are virtualized and so on, you can serve multiple end users catering to multiple applications at the same time in parallel, right? So cloud is limited as of now, right? So cloud has immense power, and this power can be fully exploited if it is seamlessly integrated into our physical lives. That means providing the real world's information to the cloud in real time and getting the cloud to act and serve us instantly is something that is desired. So in sensor cloud, we are talking about adding the sensing capabilities to the particular technology of cloud. So on one hand, cloud computing has limited power. You can add sensing capabilities to this cloud technology. On the other, if you talk about, in silo sensor networks have their own specific limitations too. Sensor networks, because of the scale of the sensor networks, and in which they can be deployed, the challenging environments in which they are deployed, and so on. And so there are some there is no standard vendor, so there is no standard design for sensor networks, right? So there are very, very localized kind of vendor specific designs that are deployed in different parts, right? And the sensor data, they cannot be also easily shared by the different groups of users, right? Sensor networks are also very deficient in terms of their computational capabilities, storage capabilities, and how do you handle large-scale applications, particularly in runtime, in real time. So, so these are some of these different limitations of sensor networks. But another limitation, which is particularly very important, is that the sensor networks are typically fixed for a particular user and for a particular application, and they cannot be easily changed once they are deployed, right? But so when we talk about sensor cloud, typically this is not so. So so you can serve multiple users at the same time, serving different applications, and so if there is some kind of a requirement to change the stakeholders, or if there is some kind of a requirement to change the type of applications to be served, etc., these can be done in real time, right? So there is a need, basically. We have seen that cloud computing technologies also have some deficiencies. Sensor technologies also have their own different deficiencies, right? So there is a need to integrate sensors with cloud so that the acquisition of the data feeds from the numerous sensor networks in real time can be processed in real time in order to make some critical decisions, and we can have very swift data processing using the immense processing power of the cloud to provide quick response to users. And what I told you, not single users, multiple groups of different types of users catering to different types of applications, connecting to different types of applications. So this is how typically a sensor cloud architecture looks like. At the very bottom, you have different types of sensor networks, physical sensors deployed in different clusters maybe, or different geographical regions. And these different physical sensors could be taking care of different types of application requirements. So then you have the sensor cloud infrastructure. You have different components for offering sensor services. In the same way as you have web services, you have sensor services, right? So these different sensor services can be taken care of at this particular level. And through the web, basically the end users or the service registers, they could be made available this kind of data that is coming from these physical devices. So the whole idea is that this looks pretty similar to regular sensor networks, but the whole idea is that you can have large number of different types of applications being run at the same time using the same physical layer, right? Using the same physical network, right? So basically a sensor, due to its virtualization capabilities, can be serving multiple applications at the same time, right? Physical layer, same device, but at the application level, catering to multiple applications at the same time. And the beauty is that these different types of sensor feeds, these could be combined at the same time, and you can make attractive services to be made available to the end users. So this is the logical view of sensor cloud. Again, so I actually let me just give you some pointers. We have large number of papers that are available that have been published in different prestigious journals, including IEEE transactions, IEEE journals, transactions, conferences, and so on. Just go to my Google Scholar profile, or you can even search in the internet, and with my name and sensor cloud or sensing as a service, sensors as a service, like that. If you search, you would be able to get large number of different papers that I have in this particular domain. And these are actually rich papers. They are basically, we are quite well known for our works in the domain of sensor cloud globally. So the logical view of sensor cloud looks like this. We have multiple applications catering to different types of users or user organizations, multiple browser interfaces through different types of login. You can get sensing services corresponding to these different applications based on the data that comes from the very bottom. So build a sensor cloud, it looks very attractive, but at the same time, technologically, it is very challenging, right? So, so many different challenges will have to be taken care of. These are only a few. So issues of energy management, quality of service, physical sensor release, application-specific real-time data aggregation, data storage, on-demand physical sensor scheduling, basically, dynamic scaling, etc. So like that, actually, there are so many different types of physical, technological issues that will have to be taken into account. And all of these different issues, the virtualization is basically the backbone that helps in taking care of these different issues. So the enabling technology, as I said, is virtualization. So basically, what happens is that the sensor cloud infrastructure, it makes virtual sensors from multiple physical sensors. Every virtual sensor is not created from sensor network. So the grouping is more flexible, and the users can create groups of virtual sensors, right? So a virtual sensor will report incorrect results if the linked physical sensors are faulty. So monitoring of some kind is required. So this is typically what happens. You have physical sensors at the very bottom, and then you form different virtual sensor groups. And virtual sensors are formed. So virtual sensors are formed through a combination of different physical sensors, and then these virtual sensors themselves can be formed, can be clubbed together in order to form different virtual sensor groups, VSGs as these are called. So some of these different operations of sensor cloud, you have what? You have different physical sensor devices, you have virtual sensor groups, you have the sensor cloud infrastructure. So through a user interface, web-based user interface, you have the physical or registration of the physical sensors, creation of templates for virtual sensors, request of virtual sensors, use of virtual sensors, finish of virtual sensors. Once these are used, basically, these virtual sensors are going to be deleted, right? So the deletion of the virtual sensors and even the deletion of the physical sensors also may be required, right? So this is typically what a sensor cloud infrastructure looks in. So, issues such as data processing, routing, power management, clock synchronization, localization, fault detection, these are all different issues that will have to be looked into. So you can either directly have this kind of a stack built on top of your physical sensors, or this could be built on top of the sensor cloud structure in order to serve them in a sensing service way. So there are different actors in sensor cloud. Sensor owner, who owns the physical sensors, allows others to use these physical sensors through the sensor cloud, and then obtains the rental fees from these physical sensors. Then you have the sensor cloud administrator, which manages the sensor cloud infrastructure service, prepares the templates for the sensors, and charges for the delivery of the sensor cloud infrastructure service. And on top, you have the end users, who basically has one or more applications or services that use the sensor data, and they can control their virtual sensors directly via a particular web interface, and they can monitor the status of these different virtual sensors. So these are how these different actors basically. So you have end user, as I said, end user, sensor owner, sensor cloud administrator, and like that. So these are how these different the actors which are going to act on the particular system. Okay, so basically, so typically in a sensor cloud platform, what you need is a web interface, right? So this web interface typically has a portal. The portal provides the user interfaces for the sensor cloud infrastructure. Then you have the clients which use these services that are offered by the sensor cloud infrastructure via the web browsers. And then you need some kind of a provisioning to offer automatic offering of these virtual sensor groups and combining them from the virtual sensors. And then you have the resource management using the resources for the virtual sensors and the templates for provisioning. There are other components too. For example, monitoring. Sensor cloud infrastructure provides monitoring mechanisms.
Sir, which portal we use it here in implementation?
Could you repeat what you were asking?
Portal, you mentioned portal last slide before the
yes,
slide.
Portal. Yes.
Portal, like AWS or what?
It's it's like a portal, right? So what is a portal, right? So it's like a portal. It's a web interface through which the users they interact, so they can do provisioning. They can
AWS, Google Cloud, or Azure, or what? Which portal?
It depends, right? So for example, we have not used any of these public clouds, right? So we have built our own sensor cloud infrastructure where we have, so it is not using, so if you are using Azure or anything like that, you might be able to build your system on top of the portal that or basically the system that they offer, right? So on top of that you can build, but it is not necessary, right? So I'm just talking about in general what happens. So it is not necessary that you have to build on that. So typically, so we built our own sensor cloud platforms completely from scratch. We do not really use any of the public cloud for doing it.
Okay,
but
so
it can be done, right?
you mean we will build the portal?
Yeah, if required. I mean, you have to build the portal, right? You have to build the portal.
Okay.
But the point is that whether you build it from scratch or whether you use any of these public cloud web interfaces that are available, that actually depends on the developer,
Okay.
right? So depending on the requirements.
Thanks.
So I'm almost done. So just another 1 or 2 minutes. So then you have the virtual sensor groups. Basically, sensor cloud infrastructure provisions these virtual sensor groups for the end users. And at the top, at the very bottom, you have the sensors, which are basically these physical sensors from where the sensing is done, right? So this is typically the system architecture of sensor cloud. As you can see, this is like a swim lane diagram, right? Those of you from software engineering, that's what is a swim lane diagram. So it looks like that. So these different, actions between these different end users, these different stakeholders, how things are done, what are the different steps. These are all also provided over here. I'm not going to go through them, but most of it, if you go through these basic papers that I told you, in case you are interested, you should be able to, if you want to build a sensor cloud infrastructure yourself, so the literature that is available, you can use it in order to, build this kind of system. So there are so many different research challenges that are there, apart from the ones that I told you. One of the issues that we worked on is something called the issue of caching. So basically, the data that comes from the physical network, how do you process it, right? So if you are talking about a simple, simple sensor network kind of application, right? So this data will have to be, it has to be immediately. It will have to be processed somewhere, right? But typically, when you are talking about sensor cloud based platform, you can build based architecture. So there could be an external cache, there could be an internal cache, and there could be a synchronization between these external and internal caches. Because so why I will tell you why this is very important is to use some kind of a cache and something similar to this is because some of these data actually these are not updated in updated continuously. For example, temperature data, right? So temperature of the environment, outdoor temperature. So these temperatures, they do not really change too fast, right? So many times it is not necessary to probe the physical sensors continuously, right? So typically, if you have something like an external cache, and this external cache, from the external cache, this data, this could be retrieved in order to serve the different user specific requirements corresponding to these applications, right? So like that, so it's a combination, it's a synchronization between this external and the internal cache, through which you can offer some improved levels of efficiency in the sensor cloud infrastructure. Similarly, we have worked on other problems like target tracking. Target tracking is a very important problem in regular sensor networks, and in sensor cloud, we have shown, like, if you are using sensor cloud infrastructure instead of wireless sensor networks for surveillance or target tracking or object tracking kind of applications, so how one can have improved efficiency of target tracking, that we have shown in this particular paper, which was published in IEEE Communication Letters in 2014 itself. So very quickly, just 1 or 2 minutes more I will take in order to run you through some of these technologies that we have built in the Swell Lab. This is actually not up to date. I didn't find time to update the slides, but so and just quickly I will show you some of these technologies. Interoperability in IoT is one of the things that we have been working on, and we have built devices which are plug and play, and so you can basically have interoperability between different standards: 802.15.4 with 802.11, 802.11 with 802.3, and so on. So between different standards having interoperability, we have built some plug and play kind of device, right? We have a lot on UAVs, UAV networks, right, forming completely flying system. And also, not only that, we have also gone ahead and we have systems which can have flying sensor network and the terrestrial sensor network synchronized together in order to get a holistic view of the 3D space. Right, so these are some of these pictures from the different swarms that we have built in our labs, in our lab, and we have deployed them and tried them. Basically, not deployed, but we have made different test trials in the campus, IIT Kharagpur. We have built and we have tried a couple of. These are actually a couple of years old, and since then, actually, the systems have improved a lot. We have done some underwater networks based systems. We have built the underwater model, which is pretty cheap, and it can help in communication. Even we have tried multimedia communication, which is actually very very state of the art, given the constrained nature of these different sensor nodes, acoustic nodes, right? So so we have done that. And we have also some popular simulators that are used, NS3 based simulators for underwater sensor network. One is basically NS3 based, the other one is the MATLAB based simulator. In health, so we have the Ambusen system, and later on it evolved into something called the AP1 system for end-to-end monitoring of patients who are traveling in an ambulance from one hospital to another, right? So this is basically a system for which patent was filed, and then we have our own different sensor node. We have the SWAN sensor node. It is not very similar to, I mean, it's very similar, but the thing is that it is not the same as these public, open platform based sensors that are available. So this is purely actually developed from scratch. In agriculture, so we have these are actually real pictures that are taken from our deployed sensor nodes in different locations. These are some of these IoT nodes that you can see over here, deployed in different parts of the fields in different locations. And this is called the AgriSense system. And we also built a sensor, for monitoring the water level ourselves. So these are some of these technology. Actually, there are many others that are also there, but but I didn't find time to update the slides. So So these are some of these books, and again, so 2 more books which I mentioned at the very beginning. One on the introduction to IoT and the other one on introduction to Internet of Things and Industry 4.0. So in case you are interested, you can get access to these books definitely by the end of this year. Right, in another 2 weeks, thing will be there in the market for sure. Okay. Okay, so these are some of these media coverage, and this is the team. Some of them have already graduated, and again, this picture is also not updated yet, right? So these are some of these happy faces who work tirelessly in order to make things happen. Thank you. So if you have any question, I would be happy to answer a few.